there's only one other special form in this little scheme interpreter, and that's lambda. And as I said a little while ago, in this trivial scheme interpreter, the value of a lambda expression is the expression itself, because that's how we're going to represent non-primitive procedures. Yeah?
So in this interpreter, it's the procedure itself, you said, as opposed to?
It's the lambda expression itself.
As opposed to the body?
Well, not as opposed to the body. The body is part of the lambda expression. Okay? We could pick some other. So if I were being really elegant about this, instead of saying exp at the end of that line, it would say make procedure lambda formals of exp, lambda body of exp. And make procedure would return a list of length 3 whose car is the word procedure, whose cater is the formals, and whose cateter is the body. But it so happens that I have almost exactly that, except instead of procedure at the front, it says lambda at the front. So I'm just going to use that. Okay? When we get to the real environment model of evaluation, you will see then that in the real scheme, the result of a lambda expression is something more than just what's in the lambda expression itself. And then there's going to be a difference between lambda expressions, which are input, and procedures, which are kind of output of this evaluation process. Okay, but in our simple evaluator, they're the same. So if it's a list, I really should call list here rather than pair, but pair is theta of 1 and list is theta of n. So I cheated and called pair. If it's a list that isn't a special form, what is it? A procedure call, right? So we're going to call this procedure by calling apply 1. And the arguments here we're doing exactly what I did in that tiny one-screen version. Exactly. It's apply 1 of eval the car, which is the procedure we're calling, and map eval over the coder, which is turning actual argument expressions into actual argument values. Okay? So by now, this little piece of code right here where the cursor is blinking should seem like an old familiar friend you've known since childhood, namely 20 minutes ago. Okay? Questions so far? Okay, we only have 3 minutes for apply, so let's do that quickly. There's a bunch of comments on apply that you can read at your leisure. Here's the code. And again, the tiny version had 2 branches. Here there's 3 branches. The third is else error. So, oops. Thank you. All right. So right here we call procedure question mark. Notice that this is an STK procedure question mark. Right? It's not procedure 1 question mark. So is this an STK procedure? That's asking the question, is this a scheme 1 primitive? Because let me remind you that every procedure in STK we're taking as primitive. Right? So we get sort of at one blow STK's entire repertoire of primitives plus any procedures you may have defined in STK. Well, if it's a primitive procedure, how do we invoke it? And in Tiny, it said do magic. And here's how we do the magic in our case. We call STK's apply. Right? So if it's an STK procedure, then STK knows how to call it, and we just let STK do that. It's important that by the time we get to apply, there's no more notation, only values. Because STK doesn't know about scheme 1 expressions. It does know about values, because they're the same values. Right? There's procedures and numbers and and lists and words and sentences and all those things. And by the time we're at apply, that's what we have. We have values rather than the expressions that produce them. So we can just call STKs apply, and it'll all work. Because args has already been translated from the actual argument expressions to the actual argument values. So we're giving apply the right thing. The second case is this a lambda expression? Because when we saw a lambda expression, we returned, whoops, how did I do that? Sorry. We returned x itself as the value. And so it's a lambda. It's a list that starts with lambda, and then the parameters, and then the body. So now what I do here, why did I get louder all of a sudden? I don't know. Have you been not hearing me all this time? Is that why nobody's hands were up? Anyway, okay. This, again, is exactly what we saw in the tiny version. We call eval on the result of substituting the actual arguments for the formal parameters in the body. Our version of substitute takes an extra fourth argument, which is given here as an empty list. And what that's going to be is a list of variables that we shouldn't substitute for because we're inside a lambda that's inside a lambda. That funny case that I talked about over there. Don't even think about that. Never mind how substitute works, because it's not part of the real scheme. What you should understand from apply 1 is that an STK procedure is a scheme 1 primitive, and that lambda expressions are how we represent scheme 1 non-primitives. Okay? If it's a primitive, then we have STK call it. If it's a lambda-created procedure, we evaluate its body after substitution. Okay? The rest of this code is sort of data abstraction a little bit, and then substitute, which is a big mess. And then at the end of this code, there are some examples of using it because since we don't have define, if we want recursive procedures like factorial, we have to make them using the Y Combinator